Hey guys, back again. My last video there got cut off, and it was probably one more of the complicated ones, but what we're going to do is just do another problem here. Let's go in the opposite direction. Let's take some water at 60 degrees, 1 kilogram. There's my water in a jar. C value of water is 4186. That's the specific heat value. And we're going to find out how much Q, or how much energy, has to be removed to end up with all ice at minus 10. So we're going to take this water and we want to cool it all the way down so it's a block of ice, and it's going to be at a final temperature of minus 10 degrees. Now C value of ice is 2010, so we keep that in mind, and we want to find out total energy. So we will have a phase change. Remember, when there is no phase change, MPC, we use Q equals MC delta T. I don't know what happened there. We use MC delta T, but when there is a phase change, we have to use ML. That's the latent heat. So there's no change in temperature, there is. So what's the total energy going to be? Well, Q total is going to be how much energy it takes to take the water from 60 to 0, right, the freezing point. How much it is to freeze the water, and then how much, or convert it from liquid to solid, think of another way, and then how much to go from 0 to minus 10 when it is all ice. So we really have three mini problems inside of this problem. So let's go through these one at a time here. Alright, to go from water there, we're not going to worry about it positive, negative. We know we are removing it, so it would be a negative. But since there's a temperature change, that Q for that first part is MC delta T. We have a mass of 1 kilogram to make it easy, 4186, and the change is 60 degrees. It goes from 60 to 0. I don't say it's minus 60, I just say it changed by that much. And if we go through here, we have a 0, there's a 6, 36, 3, 48, 50, 41, what was that? 51, 5, 11, 1, 24, 25, 251, 160 joules. I'm sure one of my students will let me know if that's wrong. Let's see, 36, 48, 51, 5, 11, 1, 20. Yeah, it seems about right. Alright, that's how much has to be removed to take us from all liquid water from 60 down to 0. Alright, that's the first part. Alright, what's the next part? The next part is when we're going to cool the ice, so let's make that blue. And I'm going to do it up here just for space. Since there is no temperature change, the temperature here is constant, 0, we have to use Q equals ML of fusion. Now there is also one called vaporization for a boiling point, but this is when we boil things. Since this is solidifying, going from liquid to solid, or solid to liquid, or going the other way, we use MLF. That's going to be 1 times, it's about 330,000 ballpark, not exactly, but close enough for what we're doing. 330,000 joules. Alright, so that's how much it takes to do part 2. If we remove 251,160, we end up with, at the icing point, freezing point. And if we remove another 330, we've taken the ice, liquid completely to ice. So now we want to look at the final part where we're just going to take that ice down to minus 10. There is a temperature change, so we can go back and do MC delta T. The only thing that's going to change here is still 1 kilogram. 1 kilogram of water becomes 1 kilogram of ice. We have to use a C value of ice, which was 2010, and it changed by 10 degrees. So that becomes 2010, another 0, 20,000 there. So if we want to put all these numbers together here, we have 251, 160 plus 330,000 plus 20,100. We'll come up with a final number of joules it takes to remove, and it's implied that it's negative, to take this liquid all the way to a solid. And we should know that if we take all that and 100% it, put it back into that cold ice, it would go completely back up to water at 60 if we did not lose any. So there it is. Hope you enjoy. Thanks.